pipeline and subsea engineering in the Department of Naval Architecture, Ocean and Marine Engineering. My background is I'm a metallurgist, and I started in the power industry and then moved into petrochemicals and chemicals, and then into oil and gas industry. And then I left industry to come and take up an academic career, firstly at Newcastle University and then at the University of Strathclyde.
Okay, and then so what brought you to the AMRL then?
Firstly, it was through a master's project looking at a particular component and the material of that component. And I guess that started this engagement with the AMRL, which has then moved through other master's projects to sort of personal scholarship, I would say, to helping out with industry projects that we had, to finally initiating an industry project which we're currently working on. So I guess it's a journey and a progression through master's projects to finally a industry project that we're working on. So through the whole sort of academic journey, I guess.
So is it the way, like, does the Naval Architecture Department, would you use the AMRL's equipment then as such? Is that how the sort of...
No, so within our obviously the Naval Architecture Department has its own specialist labs for undertaking research into how's the best way to describe it? So the Kelvin Hydrodynamics Lab is looking at wave structure interaction, and that structure could be a ship or a offshore platform or a renewable device. And so they do a lot of experiments in looking at how water flows past structure, and also about stability of those structures, particularly for ship-based structures. You basically want them, I'm not a naval architect, you basically want them to stay upright, so they do a lot of that sort of research, both in their and applied to teaching as well. So we also use our hydrodynamic labs for teaching. Our labs are particularly related to ocean engineering, naval architecture and marine engineering. And whereas what the AMRL provides is complementary to our facilities, but often it doesn't make sense. And I guess this is what I found particularly attractive about the AMRL, and the fact that it is a faculty facility, is the fact that you don't need to be doing research in naval architecture or aerospace or electrical engineering, is that materials is in all of that. And maybe I'm biased as a metallurgist, but materials is in all those branches of engineering. So for me, it's very important that the materials lab is a facility which is available across the engineering departments. It also provides, I guess, a way of sharing knowledge and expertise and experience across all of the different labs. So the way that we materials which are used in maybe a saltwater environment, similar materials could be used in other areas of engineering, maybe biomedical, these kind of things. So I think the fact that the AMRL is a faculty facility is very important, and that it doesn't really it can work across all of the engineering departments, I think, and across the wider university. I think that's really important. So yes, we do have our own labs, but they are specific to what we do research in and we teach, whereas AMRL provides that level of materials testing that we still need to do, but we couldn't support the facility by ourselves, if you see what I mean.
It's so interesting with the broad range of projects that the MRL have covered, though, like, because I came to them with my master project, so I only really knew they did like mechanical engineering side, but I didn't realize they literally help so many different departments, but then also so many different industries, like seeing they've done medical related projects and then oil and gas to renewables, so it's such a broad scope.
Yeah, exactly. And I think it's more the fact that materials are involved in all of those industries, and materials have to perform in all of those industries to the required specification, and also have to be specified correctly. And so I guess to me, it doesn't matter what that industry is, that the facilities that the AMRL have, that's why it's such a good facility to be able to access, because it works across a number of different industries and departments.
Just so, how would you describe your experience having worked alongside them in different collaborations?
I think the main thing is the word you just used at the end there. It's collaborative. So I think the benefit of working with a university-based testing and facilities lab like the AMRL is that it's not a machine test repeat. There is an element of machine test, ask questions. Is this the right way to go? Should we be adapting this process? Should we be developing it? Is this the best? Have we got the right results? And I think it's that additional dialogue, which I think because it enhances the experience, because otherwise you could go to a test house and they would test exactly what you said in exactly the way you said it, and give you the result. And sometimes that's what you need, definitely, but sometimes you want that additional sort of interpretation on top of that. And I think that is what coming to a university setting, I think that is what one of the benefits is, that you have not only the experience of the people in the AMRL, but you also have the experience of other colleagues around the university who maybe have seen that before, or maybe have experience in that. So I think that is one of the things that working in this context brings.
I guess the personal touch as well. I found with working in with Tizzy and Fiona, they've always sort of show a lot of interest, I found, and they're always quite enthusiastic about the projects I've worked with them. They're just, I don't know, they're quite the team together, plus Mida as well. They're just good people to work with, I've found, at least.
Yeah, I think yeah, you're right. Being interested in the project is very important, and I think one of the things about metallurgists is we tend to be interested in when things go wrong, and so we're very good, I think, investigating around, well, why has that happened? And I think that is one of the things that is good about the team there, that they are asking these questions all the time, and bringing in that other experience, which is always helpful and useful.
Okay, Joe. And then just a final one. Have there been any highlights of working with the AMRL?
I think one of the highlights is probably not the biggest project. I think this is a project that we did on fatigue of girth welds, and it was a problem that was brought to us from industry around remaining fatigue life of girth welds in pipelines. And we did the testing and we presented the results, and that was great. Everybody was happy. But there was something around the results that we were getting, which were not results that we were necessarily expecting to get. And therefore I got an MSc student to look at why we were getting some of the interesting sort of failure locations that we were. And she worked together with my research associate and the team at AMRL to do some particular strain gauging around the test, so to run the test again and do a lot more detailed analysis than the client was actually wanting, but we were all interested. Oh. And my research associate then managed to simulate the same thing with finite element modeling, and we were able to sort of demonstrate why the test piece had failed in the way that it did. But it required that design of experiments around where to strain gauge, how to do the test, the metallography around making sure we could then model that correctly. So that it brought a lot of different aspects of the AMRL together in terms of the testing, in terms of the Met lab and the measurements, in terms of the SEM that we were able to use. So I think that is probably one of the most exciting experiences in terms of a project that has finished. We're working on a project at the minute, which again is throwing up sort of interesting side avenues to go down, and I guess we're always writing down those side avenues and thinking that would be a good PhD, that would be a good so I think that is, I guess what I was saying before, it's more than the problem that you've been brought in to solve. It's more than that problem, and it's all the sort of conversations and avenues off that make it quite a fulfilling experience, I think, but certainly from an academic point of view.
Oh no, I love that. It's like you think there's gonna, well, it never is the case though. You never really think, it never really ends up just being a sort of straight road. Like even for like my dissertation in 4th year and then my group project 5th year, things never quite go to plan, but then it's the sort of journey that makes it. Like I quite like the bits that sort of the branches that kind of come off.
Yeah, exactly. And I think yes, so you will have a very defined way of what you're going to do, and then you realize that the specimen's too small to do that, or the material isn't what you thought it was, or so there are lots of things that get thrown up. And I think what is most satisfying is then trying to solve those problems, trying to change the technique, trying to manufacture the piece of equipment that you need to modify the test machine. It's all those other parts that make the project so much more interesting, I think.
Thank you so much for talking to them.
No problem. Thanks.
Enjoy the rest of your day. See you later.
Bye.